So in this video, we're going to prove that arctan x equals a half log 1 plus x over 1 minus x and consider what restrictions there are on this. So I'm going to start by writing y equals arctan x. Alternatively, I could write tan y equals x. Now we know that tan y is sine divided by cosh. So the expression in terms of exponentials for sine is e to the y subtract e to the negative y, all divided by the expression for cosh, which is e to the y plus e to the negative y. Now, both of these expressions are divided by 2, but because they're both divided by 2, I've just omitted them, equals x. Multiplying by the denominator on this side, I will get e to the y subtract e to the negative y equals x, brackets, e to the y plus e to the negative y. Expanding out the bracket, you can see that e to the y subtract e to the negative y equals x e to the y plus x e to the negative y. Now, I'm not happy with these negative powers, so I'm going to multiply every single term by e to the y. So I'm going to get e to the y squared, which is e to the 2y, subtract 1, equals x e to the 2y, plus x times e to the 0, which is 1. Now, obviously I want to make y the subject of the formula because I'm after y equals, so I'm going to move that onto the other side. I'm going to add 1 onto both sides. So I'm going to get e to the 2y subtract x e to the 2y equals, adding 1 onto both sides, I'm going to get 1 plus x. Factorising out the e to the 2y gives me e to the 2y brackets 1 minus x equals 1 plus x. We can then divide by the 1 minus x to give us e to the 2y equals 1 plus x over 1 minus x. To eliminate the exponentials, I'm going to take natural logarithms of both sides. So 2y equals log of 1 plus x over 1 minus x. Divided by the 2, y equals half log 1 plus x over 1 minus x. Now we do have to consider what restrictions we can place on this. So obviously we can't have x being 1. We also can't have x being negative 1 because that will result in log 0, and we know log 0 doesn't exist. And in fact, if we consider any value bigger than 1, for example 5, then obviously the numerator is fine. We'll get 1 minus 5, which is negative 4. We'll end up with a negative fraction within this, and we cannot have logs of negatives. So the only way we can guarantee that we don't have a negative number within this bracket is to place the restriction of negative 1 is less than x is less than 1. Thank you very much, and don't forget to subscribe.